If figures are similar, their angles are congruent, their sides are proportional. Their angles are congruent, their sides are proportional. So those are the two biggest things you need to take away from this unit. And if their sides are proportional, there's always going to be a scale factor. And you find that by putting the second figure over the first figure. So, in our warm-up, it's saying the triangles are similar. That is true. Hypotenuse over leg equation. Are you talking about geometric mean, Quan? Okay. You can watch the lesson, or you can ask some questions over the homework, and I can work those. So in this one, they are similar. Check. So their angles are going to be congruent, the corresponding angles, of course, and the sides, the corresponding sides, are going to be proportional. How many trues did y'all get, and how many falses did y'all get? Oh no, I didn't post it. I recorded it. It's on YouTube. It's on YouTube. It's just not on my website. If it's ever not on my website, you can just go straight to my YouTube channel. Search for Mrs. Tanton. Sorry about that. It's recorded. It's uploaded. It's just not posted. So you can watch that tonight. You'll have some stuff to do tonight. All right. I'll go post it as soon as we're done with this warm-up. Okay, number one, everybody type in true or false. I should see lots of typing. Number one. AE is to ED as AB is to BC. 1 is to 1 as 2 is to 2. I'm just waiting for some more people to answer. Now, normally we don't put partial sides in proportions, right? We just don't do it because a lot of us don't understand when you can do it and when you can't do it. Well, number one is one of the times when you can do it because this is the whole side over the partial side equals the whole side over the partial side. So that actually does agree, and that one actually is true. Now let me tell you what students try to do that is not okay, and students do this all the time. Are you watching? I hope you're watching. That's your job. Okay. A lot of times, I don't know. I'll do 9. Okay. A lot of times people do this. 7 is to 3 as 4 is to 9. That's a time when you cannot use a partial side because 4 is the entire side, 9 is the entire side. So that's like saying whole is to partial as whole is to whole. So do y'all get when you can use a partial side and when you can't? If you're going to use a partial side in one part of in one ratio, you just have to make sure you also use it in the other ratio, and then you'll be okay. Let's move on. Number 2. If these two triangles are indeed similar, then is EB parallel to DC? It is true. Does anyone know why it's true? Does anyone know why it's true? Okay, you have some catching up to do, Tahani. You missed 2 days, right? Thursday and Friday. No, lines can't be similar. We agree that if those two triangles are similar, the angles aren't similar if they are not parallel in the pic. Wait. Angles are never similar. Angles can't be similar. Angles are either congruent or not congruent. Yeah, okay. So angle AEB is congruent to angle ADC. Angle 1 is congruent to angle 2. And the reason is because E is listed first and D is listed first. If triangles are similar, then their angles are congruent. Now, if angle 1 is congruent to angle 2, then what we learned last semester is that if corresponding angles are congruent, then the lines are parallel. So we proved the lines parallel because the corresponding angles are congruent. And that is the answer. Oh, okay. Moving on. Number 3. AB is to BC. AB is to BC as EB is to DC. Yay, very good. That is definitely false because this is whole is to part as whole is to whole. That's the one I was talking about that we cannot do. Let's move on. Number 4. Do those angles go together? AEB. Oh, we already talked about that. And ADC. Yep, those are corresponding angles, and corresponding angles have to be congruent if our triangles are similar. True. So they were all true. 1, 2, and 4 were true. All of them were true except for number 3. Let's look over our homework answers. Once again, I apologize for not having the lesson posted on the website. YouTube is your backup. If the lesson isn't posted, I'll go do it right now, though, as soon as I'm done talking. Let me know if you want me to work any of these. There weren't any K-level problems on here because we got all of these from the textbook because this was the first time we taught this lesson. But it was really, really good practice with applying what we learned. And one of these will be on the test, just a basic one of these. It won't be a tricky one, okay? You want me to work one just to jog our memory? Can you give me one to work just to kind of make sure we remember what we learned 3 days ago? Okay, number 4. So, when we are doing these type of problems, when we've got A, we've got a right triangle, and B, we draw the hypotenuse from the right angle, the altitude from the right angle. When we are doing these type of problems, then we can use our geometric mean shortcut. This is X, this is 40, and this is 50. So you do need to memorize those proportions that we learned. There's one proportion when you're looking for an altitude, and there's one proportion when you're looking for a leg. Which one are we looking for here? X, it's the altitude. We're looking for the altitude. So you're going to use this one. Leg over, oops, not leg, seg. I meant to put seg. Sorry. I think I called it seg 1. Seg over altitude equals altitude over the other seg. When I say seg 1 and seg 2, I'm talking about the hypotenuse has been broken up into segments. So seg 1 would be one of the segments, and seg 2 would be the other segment. So the altitude is the geometric meaning of the pieces of the hypotenuse. So let's set it up. Segment number 1, 40. 40 is to X as X is to. Segment number 2 is not 50. Segment number 2 is 50 minus 40. It's 10. So you do 40 times 10, and you take the square root. Could some of you stare at this problem and just go, square root of 10 times 40? The square root of the product? Absolutely. You don't have to set up that proportion if you already know the tricks, if you already know the rules, which is honestly how I solve it. Okay, I'll do 12. I'm going to do 12. I'm not going to do 12 and 13 and 10. But I'll do 12. We already did one like 10 in class, so you can watch the lesson tonight. Now that you know, it'll be posted. Oh, you were saying 10. You were answering me. Got it. Okay, so I'm going to do number 12, and then we're going to move on. Number 12. Okay, this is one where you have to set up a proportion. You can't go straight to square rooting because we've got some x's. Okay, anyways, are we looking for an altitude or a leg? Because that's going to decide which proportion we use. We're looking for a leg, so we're going to use that proportion. The proportion was, you should have this in your notes, hypotenuse over leg equals leg over adjacent segment. The segment of the hypotenuse that's closest to that leg. All right, let's fill it in. The hypotenuse is 12. The leg is x plus 3. The leg is still x plus 3. It's the geometric mean, so it should be repeated. And the segment of the hypotenuse adjacent to what we're looking for is x. So now we're going to cross multiply. 12 times x, 12x equals x squared plus 6x plus 9. I'm going to subtract 12 from both sides. 0 equals x squared minus 6x plus 9. Hope that's okay with everyone. I kind of took the factoring quickly, but I am not your algebra teacher, so I'm not going to reteach factoring. Are we okay with that? I hope so. X happened to be 3. 3 is the number that makes that leg a geometric mean between the whole and the part. All right. Let's get into working some problems, reviewing for that test, okay? So let's just remind ourselves. You can write this down if you want, just kind of a summary of what we've learned. 2 triangles are similar if the angles are blank and the sides are blank. Yes, you do have to take the test tomorrow. Yes. You only missed one lesson, and you'll watch it tonight. There's only one problem on geometric mean on the test. You still should take the test tomorrow. I don't want you to get behind. Okay. Yes, angles are congruent. Sides are proportional. Very good. Scale factor. How do you find a scale factor? I'm going to do 2 just quick examples. I meant to do inches there. We'll try that. There's 2 different, these are totally separate examples that I want to go over. Okay? So scale factor, very good. I taught you, you wouldn't necessarily see this everywhere. I taught you second over first. So if we're dealing with the triangles, those don't have any units. So you don't need to worry about unit conversion. The scale factor, very good, would be 7/3. 7/3, that's the scale factor. That gets you from here to here. If you multiply by 7/3, you will get from the small triangle to the large triangle. Now on the scale I wrote 1.5 inches equals 20 feet, like if you are taking a drawing and making it larger. This one, the units have to match. I'm not cross multiplying, so the units are not going to cancel. So I would do second over first, but I'm sad right now because my units aren't canceling. So I need to do something about that. So I'm going to take my 20, and I'm going to multiply it by 12 because I know 12 inches are in a foot. And I get 240. So now I've got 240 over 1.5. I'm happy because my inches cancel with my inches. Because scale factors should not have units. Scale factors are unitless. I've talked about that before. So then we would just reduce 240 divided by 1.5. And our scale factor would be 160. It's a huge scale factor. I just made that up. Sorry about that. Okay, so this scale factor for this right here would be 160, and it doesn't have units. Okay, let's move on. Let's work some problems. If you don't want a hint, don't look at the board, but I'm just going to work it a little bit, do a little bit of work on it. This is leftover from algebra. This is algebra review. Ooh, this is an ugly one. This has a leading coefficient. Woo! Let's see, I've got minus 5x, and then I bring the 10x over. Got plus 2, so I need to do minus 20. Ooh, there's good news about this one. The good news is, when I bring everything to one side, there's a 3 in every single number. So I'm going to get rid of that 3 because I don't like having to factor with a leading coefficient. So I'm going to pull a 3 out. Oops. 3 comes out, x squared minus 5x minus 6. There we go. I needed to extend my page. Okay. So now we really don't have to worry about the 3 anymore. We just need to factor this guy. 2 and 3. Nope. Six and 1. Woo-wee. The one that you'll see on the test, I'll just go ahead and say this, it will not have a number that you need to pull out. So you might have a problem like this on the test, but it's going to already be in this form right here once you cross multiply and get everything to one side. So don't worry about what we did when we pulled out that number. You just need to be able to factor something like x squared minus 5x minus 6. Okay? That is important that you can factor that. All right, let's get back to an easy one. That was not a good first problem. Let's go. Who's going to be first? Minjung wins. Oh, but George wins extra. Minjung got a half right. So when you cross multiply, 4 times 16 is 64. And x times x is x squared. And so x is plus or minus 8. Now, if I said x is the geometric mean of 4 and 16, which it does look like a geometric mean problem, then your answer would only be 8 because a geometric mean has to be positive. Anyways, this is not a geometric mean problem, so x is actually both of those answers. Very good. All right, we haven't done these in a while. Let's do these. The ratio between the circumference of two circles, guess what? We could care less that these are circles. Remember, all we care about is dimensions. What dimension am I in? Circumference. Is that 1D, 2D, or 3D? Yeah, very good. It's 1D. If it doesn't have the word area and it doesn't have the word volume, it's pretty much 1D. So, 1D is all I care about. Now I can cross this out. Is 3 to 5. Find the area, 3 to 5. And the area of the smaller circle if the area of the larger is 150. 3 is to 5 as x is to 150. I put 150 in the denominator because it was the larger one. What symbol is that, Helaman? All right, this is 1D, this is 2D. They don't get along. So you may not cross multiply. So anyways, we need to make everyone 2D because our answer needs to be 2D. Oh, you're pointing to the answer, sorry. I'm sorry if you're already done with this. I'm explaining it for those who are still catching up. So square it. Now you're 2D and now he's happy. So 9 times 150 divided by 25. And they actually didn't give us units. But on the test, if you're given units, then you need to put units. I just made one up. But on the test, you need to put units, okay? Moving on. 2 cones are similar. The base of cone A has an area of 4 meters squared. The base of cone B has an area of 64 meters squared. The volume of cone B is 100 meters cubed. What's the volume of cone B? Let's go with changing that to the letter A. Can't really, that's really silly. I hope this works out well. I can't remember which one I was supposed to change to A from last year. We'll figure it out, right? All right. 4 is to 64 as X is to 100. This is 2D. This is 3D. We want our answer to be in 3D. Remember, you can't go straight from 2D to 3D. So you need to square root and then cube. Square root and then cube. Let's go to 1D. Square root of 4, 2. Square root of 64, 8. You can call it 1/4. I would go ahead and call it 1/4. So now we need to cube it so that we're in 3D land. 1 to the third is 1. And 4 to the third, I thought so, 64. Okay. They're both 3D. Everybody's happy. So now I can cross multiply. 1 times 100 divided by 64. 25/16 or 1.5625. Yep. You get the idea even though the answer wasn't pretty. I know, I'm sorry. The heights of 2 cones are 4 and 5. The volume of the larger is 3,375. What is the volume of the smaller? Here we go. 4 to 5. Larger. 1D, 3D. You always ask yourself, what do you want your answer to be in? I want my answer to be 3D, so everybody needs to be 3D. And then you cross multiply. $1,000. Come on, guys. What is it? 1,728. Very good. Cubic inches. Okay? I'm not saying anything yet. Although I do see some angle markings that makes that little bitty, not little bitty, but one of those triangles isosceles, so that might help you. Some of y'all should already have this. Yeah, George. Yep. Very good, Minjung. I mean, obviously, yes. Let's talk about it real quick. This is an isosceles triangle because those are congruent. So if that's 10, although it's not drawn to scale, sorry, as usual. If that side is 10, then the other side's 10 because it's isosceles. And here's where we get down to, you can use a partial side. It's going to be easier, but you've got to be careful when you use it. So on this one, can you do 3 is to 5 as x is to 10? Yes, you can. But could you have done that if this was x and this is 10? No, you couldn't have. So I need you to be really careful. If you want to be consistent, the way that I taught it, you would do 3 is to 8 as x is to x plus 10. This is the way I taught you to do it, but yes, the other way will work. Part over whole is great because that way you never do it wrong. If you do part over whole, part over whole. If you do whole over whole every time, 3 is the whole side and 8 is the whole side, then you'll never get it wrong. But I know that some of you do realize you can do 3 to 5 and x to 10, and that is way easier in this problem. Either way, the answer is 6 when you cross multiply and solve. The answer is 6. Very good. Got 2 options. You can call this part right here, you can call this 48 minus x, or you can just call it y. And you can solve for y, and then you can subtract it from 48. It's totally up to whichever one of those makes more sense to you. I would do 27 is to 36 as 48 is to, let's just do y. Let's just make it easy on ourselves. Okay, so 48 times 36 divided by 27. I did something wrong. What did I do wrong? 9. Ah, sorry. No. Thank you guys, sorry. I knew something was amiss when I got an answer that was bigger than the entire side. I knew something was wrong. All right, sorry about that. 27 times 48 divided by 36. And you get 36? Yeah, I know. And there we end up with our beautiful answer of 12. I hope that's okay with you guys. Classic example of not setting up your ratio on the other side in the same manner that you set up the first ratio. So I did 27 is to 36 as 48 is to y. Should have done y is to 48. Moving on. On this one, just be careful. Make sure you know which sides go with which sides. Like I would mark my vertical angles and then I would mark my alternate interior angles. So A is across from a double arc and X is across from a double arc. So 8 and X go together. So I would say maybe 9 is to 7 as X is to 8. And then use it again. 9 is to 7 as Y is to 13. You can just cross multiply both of those. So find 2 sides that go together that correspond, like 9 and 7, and then use that to find both of your variables separately. 8 times 9 divided by 7. Ooh, that's ugly. Math enter, 72 sevenths. 9 times 13 divided by 7. So 72 sevenths and 117 sevenths. Do not put the decimal as your answer. You can't put 16.7 because that decimal goes on forever. You have to put the fraction. Please, on your test, put the fraction. Alrighty. This is a good example of what I've been talking about over and over and over. To solve for y, you can say 12 is to 4 as y is to 5. That will work. It will. But when you're ready to solve for x, you have to say 12 is to 16 as 9 is to x. I hope you understand the difference. You'll understand the difference in solving for y is different than solving for x. Because 9 and x are whole sides and whole sides. Y and 5 are a whole side and a partial side. So just please be aware and careful of that. Okay. 12 times 5 divided by 4. 15. Y is 15. Well, I like these numbers better than those last numbers. 16 times 9 divided by 12. 12. 12 is the geometric mean of 16 and 9. Do you notice how much geometric means show up now that we've learned it? They're everywhere. Okay, let's move on. I'm actually going to have you do this one. This is going to be our last whiteboard problem because I need to give you time to work on your review sheet and ask me questions. We have not talked about mid-segments in a long time. I taught a lesson on it, we had a worksheet, and then that was about it. So this is a mid-segment problem. TN, TE, and NE are all mid-segments. UA is 30, PE is 6, up is 15, find the perimeter of UPA. I think I meant to find the perimeter, of T, N, E. Let's do that. Find the perimeter of T and E. Sorry. Because I like that better than finding the perimeter of UPA, because that's too easy. So we learned that a midsegment, the length of a midsegment is equal to the length of half the base. Midsegment is half the base. So how long is TE? It's 15. How long is NE? It's 7.5. And how long is TN? Well, this is 6, this is 6, this is 12. 12 divided by 2 gets us 6. Yay! Add them up. 28.5. I'll take it. Okay, like I said, I do want you to work on your review sheet now.